Okay, here's our pre-test that we took, and so now hopefully we're a little bit more prepared to take the actual assessment. So numbers 1 and 2, I'll try and do these in sections, and 1 and 2 go together. All it says is solve this equation and find out when it equals 0. So what they've graphed is the related equation. You can see it's still x squared minus 10x plus 25. So it's still the same equation, but now they've graphed all the solutions to it. We're looking for a particular one. When does the y value equal 0? And that's right here where it crosses the x-axis. Now it's kind of hard to read that one, but if you look at it close here, you'll see that this is 2, 4, 6, 8. So this must be right between 4 and 6. This is 5. Now it just touches the graph of the x-axis there, so it only equals 0 right when x is 5. But we count that as a multiplicity. So in other words, we count that answer twice. So you could write x is 5, or you can put f, and then we put m2 behind it for multiplicity 2. And that again just means it happens twice. Let's look at number 2. Number 2 is a little bit easier because you can see there are distinct spots where it crosses the x-axis. So again, this is going by 2, 4, 6. So it crosses right here at x is 2, and it crosses right there at x is 4. And so those are our answers. The x values of 2 and 4 would make this equation true. And you can test that. If I were to put a 2 in here, you'll see that the left side equals right side. 2 squared is 4 times 2. This is 8 plus 16. And over here it'd be 12 times 2, or 24. And 8 plus 16 is 24. So you can see the 2 works in there. 4 would likewise work. And that's it. If they give you the graph, just find the x-intercepts. Where does it cross the x-axis at? Here it was just 5 twice. Here it was at 2. And right there it was at 4. Simple enough. Next two type are simplify radicals, okay? And we talked about this extensively. But in the first one, number 3, the problem with this is one of our rules is no radicals in the denominator, and here we've got a root 3 down there. So in general, what you do, since we're dealing with square roots, is you try to make a perfect square. So you take it times another root 3. What that does is gives you a radical down here, but now it's got 2 3's in there underneath it. So that means the 3 gets to come out. And that's what we wanted to happen. We built it so there'd be 2 3's underneath it so that the 3 would come out of the radical. No radical in the bottom, we're done. The next one here is very similar to it, except because there are 2 terms down here, you don't multiply by root 5, you have to multiply by the conjugate. Okay, so the conjugate is exactly the same thing as the denominator when it has this binomial kind of look to it. Binomial meaning 2 terms. So you can see this has got a 2 minus root 5. Those are the 2 terms. They have a minus sign, so I multiply by the same 2 terms, but with a plus sign in between. Just always opposite. And so if you remember that, then the rest of it is just carrying it out. So you distribute here. 2 times 7 is 14, and 7 times root 5, we just write 7 times root 5. And this you can get out your calculator for, but I'll show you how to do it by hand. You go 2 times 2, and you go 2 times root 5, and here's the beautiful thing. That 2 root 5 looks kind of messy, but every single time you'll also end up with this negative root 5 times positive 2. They'll have opposite signs, and so this radical part every single time disappears. And in fact, when you multiply 2 binomials like this, you only need the first 2 multiplied together. That's 4. The middle stuff will always cancel out, but you do have to multiply the last 2. It'll always be a positive times a negative because they're conjugates, so you get a negative every single time. And see, it's root 5 times root 5. Well, root 5 times root 5 is just root 25 or 5, so it's just 4 minus 5 down here, or negative 1. Your calculator would do that for you, okay? That's a fine answer, or I could divide everybody by a negative 1 at that point. But if you gave me this for an answer, or this for an answer, that'd be perfectly fine. So those are our simplifying radical problems. Next type, square root problems. How do we know they're square root problems? Well, it says solve using square roots, okay? Remember, these are all quadratics, ax squared plus bx plus c equals 0. And if there is no b term, no linear term, no term with just an x next to it, then you can use the square root method. So if you look at this one, we have an x squared term and a constant term, but no term with just an x. That means we can use the square root method. And the idea is to get the squared part alone, so I'm going to divide by 2 here. And so now I've got x squared by itself, and now you can just square root both sides. See, that's a perfect square now. 2 x's, and x comes out. Now on the right side, you always get plus or minus when you square root. And the square root of 3 can't be simplified, so we just leave it as square root of 3. We don't want to put the decimal. Do remember, this is 2 answers. It's positive root 3 and negative root 3. Plus or minus root 3 is what that means. Next one in the square root method is problem number 8. Nope, not problem number 8, problem number 6. Again, notice there's no bx term, no term with just an x in it. And so square root method is in order. We'll add 15 to both sides, and then we'll divide by 2. So x squared equals 15 over 2. See, now I've got the x squared alone, and now I can square root it. So undoing the squared just gives me x, always plus or minus. Now I've got a fraction here, so I always recommend separate the fraction right away. It's the same thing. And I do that so I'm ready for my next step. My next step is to see if I can break down the 15 and take something out. But 15 is 3 times 5, so nothing comes out. Root 2 you can't break down. It's 1 times 2. So we can't take anything out, but we're also not allowed to have a root in the bottom. So we'll make it a perfect square down there by taking it times another 2, root 2. Inside times inside on top, so 15 times 2. And the root 2 times root 2 is root 4, square root of 4, which is just 2 again. And there's our answer. 30 doesn't break down. If I were to factor 30, it's 3 times 2 times 5. 6 times 5 is 30. But there aren't 2 of a kind, so there's no sense. There's my 2 answers, positive root 30 over 2 and negative root 30 over 2. In this same section now is number 7, square root method. Now, it's a little bit more confusing to use the square root method on, but notice here's our x. It's trapped inside the parentheses, and the parentheses are squared. So if our goal is to get x by itself, I have to get the x out of the parentheses. And as long as the squared part is by itself, when you square root it, the square root part just takes care of that squared part. And see, now the x plus 3 is no longer squared, and it's no longer inside parentheses. So the left side, the exponent went away because I square rooted. The right side, I get plus or minus root 8, and I have to simplify that. But before I simplify it, I'm going to go ahead and finish the solve part here. Let's subtract 3. So now we got x alone. When you take a number over and you've got that plus or minus part, always put it in front of the plus or minus. Okay, now let's break down that 8. 8, we've seen it now several times. It's 2 times 2 times 2, and so a 2 comes out, and you're left with a 2 inside. And so those would be our 2 best answers. Negative 3 plus 2 root 3, or 2 root 2. Notice you keep the negative 3 in front, and then you do negative 3 and you change it to a minus 2 root 2. That's the negative part down here. Okay, so those are our are solved by the square root method problem. I'm going to zoom out here a little bit so you can see them all on that single page. Okay, so here we're simplify the radical. Here's look for the x-intercepts. Here is the square root method. We only got one method left. That was the factoring method. Sure what that was about. Anyway, so let's go to the method here. That's problems 8 and 9 tomorrow. Okay, step 1, make sure it equals 0. Now you can see the first one is done for us. This second one is not. It's got that negative 10 over there. So you want to make sure it equals 0 before you try to factor it. Now, we don't have to get super cutesy with factoring these things. you know, since this is just x squared out here, think about these binomials we're trying to factor it as. The x squared comes from the first term of each of these, so we know they're x's already. Forgot to bring my 10 over on this bottom one here. Not sure what happened there. Let's fix that real quick. So back to this top one. So I know this is an x and an x. This 16, the c term, remember this is ax squared plus bx plus c. 16 comes from this times this, and I've been calling those r and s. And we just have to figure out which product, or which pair of factors, rather, r and s give us that 16. So we want r times s to give us the 16, but at the same time they have to add up to the b value. And the b value in this case is right here, it's at negative 8. Okay, this is ax squared, so a is 1, b is negative 8 up here, and c is 16. So I want them to multiply to 16. Always start with the multiplication part. And go, okay, 16. That means r could be a 1 or 16 for s, and 2 and 8. 3 doesn't go into 16, but 4 does. So those are the factors that make up 16. Now we use the second condition. They have to add up to negative 8. Well, if they're going to add up to negative 8, at least one of these has to be negative. But because they multiply to a positive 16, it tells us they both have to be negative. So if these are both negative 1, negative 16, they don't add up to negative 8. The only way we get a negative 8 is if it's a negative 4, negative 4. They multiply to 16, and they add to negative 8. And so we now know what r is. It's negative 4, and s is. It's negative 4. Do not forget to finish the problem. Set each factor equal to 0 and solve it. Add 4, you get 4 on the right side. Add 4, you get 4 on the right side. So two answers, x is 4 or x is 4. In problem 9 here, I've already got it equal to 0. I did that. So now I'm ready. See how quick this is? You go, r times s has to equal 10. So you list your factors, 1 and 10, 2 and 5. R plus s has to equal negative 7. Remember, that's b. And so, see here, 1 at least has to be negative, but I have to be a positive. So they're both going to have to be negative so that they multiply to positive and they add to negative 7. And that's what negative 2 and negative 5 do. So now I know how this factors x minus 2, x minus 5. I set each factor equal to 0. I add 2 to both sides, and the other one I add 5 to both sides, and I get 5. So 2 and 5 are your solutions for x. So that is the solve by factoring method. Nothing too hard. And then our last one here, solve by any method you want. So I'm going to solve by all 3 of them, okay? My first choice is there's no b term, no x term, so I'm going to solve by square root method. I'll add 64 to both sides. I'll divide by 4. Now it comes out even over here. Let's see here. That comes out to 16. X squared's alone. I square root both sides. Don't forget plus or minus, and the square root of 16 is 4. So there it is, square root method. Here it is with the factoring method. See, everybody's divisible by 4, so I'm going to do that first. And so r times s, I know it's going to be 2 binomials. I know it's going to be x and x. R times s has to equal negative 16. R plus s, there's no b term, so it would have to add up to 0. So it's 1 and 16, 2 and 8, or 3, 4, and 4. So they multiply to negative 16, which all these pairs do. But they have to add up to 0, which means they have to be equal and opposite, so it can only be this negative 4 and positive 4. See, they multiply. Negative times positive is negative 16, and they add up to 0. There we go, x minus 4 and x plus 4. Set them equal to 0, add 4. Set it equal to 0, subtract 4. There we go, 4 and negative 4. Okay, and then the last thing you could do is you could graph this thing. This parabola, now remember, if you graph it, you graph the related equation, and so it equals 0, and so you graph y equals x squared minus 16. And this is essentially our parent function, x squared, but it's shifted down to negative 16. Now, I would do this on my calculator. But if you graph it on your calculator, you'll get something like this. And you will see it crosses right there at 4, and it crosses right there at negative 4. Again, the x-intercepts are our solutions. So clearly the best way to do this square root method. That's what I would use. That's it. I'll zoom out here so you can see that was our last problem. But there they all are. So kind of to summarize all this, 1 and 2, find your x-intercepts. Problem 3, you got to multiply by the denominator to make it clean up. Problem 4, you got to multiply by the reciprocal to clean it up. Okay, square root method, you get the x squared alone, and then you square root both sides. Same thing with 6 and 7. 8, you factor these things when it says factor, and use your r's and s's to figure out how it factors. Don't forget to set each factor equal to 0 to solve it. So there they all are. Okay, in a nutshell, and then the last one we did with square root method. Piece of cake. Okay, you only got to memorize really, 1, 2, 4 different things. That's not too bad.